Hey everybody, it's Mr. Carr again, and today we're going to be talking about 4.2. So this is reasoning in geometry. Well, a lot of things we're going to be talking about is very vocab heavy today. All right, so let's start off with talking about these vocab words: complementary, adjacent, supplementary, linear, and vertical angles. And there's a nice little typo on vertical angles I just realized. Let's fix that. Not vertical angels, vertical angles. Okay, so what I'm going to do is I'm actually going to pause the video here. I want you to maybe think about this. Can you see, are there any things you've seen in the past, something that you might recognize for terms? Okay, but I'm just going to, it's a lot of writing, so I'm just going to go ahead and write that down now to save some time. Okay, now that you're back, these are my definitions. I'm going to talk about them real quick. I just didn't want to spend all the time writing as well. So complementary angles, okay? So these are two angles that add up to 90 degrees. They are not angles that say nice things to each other. Kind of like you're pretty acute. All right. So complementary angles are any two angles that add up to 90 degrees. So for example, if I just say here's 30 degrees and here's 60 degrees, those are complementary because they can add up to 90. Adjacent angles are angles that share a common side and vertex. So for example, adjacent would look like this. These two angles are adjacent to each other. This is their common side and common vertex right here. Okay, so adjacent is kind of like, I like to think of it as they are attached to each other. Supplementary angles are two angles that add up to 180. And just like before, I can do something like this where I have 130 degrees and 50 degrees. Those are supplementary angles that are those are supplementary angles that add up to 180. So the next one is a linear pair. These are adjacent angles that form a straight line. So these are very specific. They are straight angles. Sorry, they are adjacent angles that form a straight line. Okay, so that's the scenario here. Now, if you notice, looks very similar a little bit to this idea, and there is a relation there. Okay, but a linear pair has to be attached to each other. Supplementary angles do not need to be attached to each other. Something to be aware of. Okay, the last one is what's called vertical angles. These are non-adjacent angles formed by two lines intersecting, kind of like in an X. So for example, like this, the vertical angles would be here and here, but also here and here. So if I say angle 1 and angle 2, angle 3 and angle 4. So if I look at these, for my vertical angles, the pair would be angle 1 and angle 2, but then separately, angle 3 and angle 4. Okay? So now we're going to analyze a little bit more about these ideas. Something with adjacent angles, complementary, vertical, and all of that. Okay? So the first one is the linear pair postulate. If two angles form a linear pair, then they are supplementary. Okay, so that's what I kind of imply with my diagram. If I have something like this, then this angle measure going all the way around is 180 degrees. So if I have a linear pair, I have supplementary angles. If I have supplementary angles, maybe I have a linear pair, not necessarily. Because remember, so definition of supplementary is that two angles that add up to 180. So it's one of those things where if I have a linear pair, I definitely have supplementary. If I have supplementary, maybe I have a linear pair. Definition of complementary, there are two angles that add up to 90. So I didn't really show this on there, but we can also have adjacent. So for example, if I say this right here, I can say that angle 1 and angle 2 are complementary. And this is using a little bit of yesterday. The angle addition postulate says that angle 1 and 2 are going to add up to the 90 degrees that's right there. Okay? Definition of perpendicular lines. Perpendicular lines form right angles. Let me write that a little bit better. Okay, they form right angles. So I kind of demonstrate that here. We show that with a little box in the corner. And then definition of a right angle is an angle that measures 90 degrees. So we can kind of show complementary angles with a diagram like this. Even though I don't say specifically 1 and 2 add up to 90, I'm showing it because angle addition postulate adds up to a right angle, and a right angle is 90. All right, so here's our first example. This is how we can apply that. Find the measure of angle DBC and CAB. So based on this being perpendicular here, I know that this is also going to be a right angle. So my initial setup is going to be this: 4x plus x equals 90 degrees. Okay, I know this is based on the diagram, I know this to be true. So 5x equals 90, divide by 5, and x equals, I believe, 18. Okay, so x, remember that is this one right here. So the measure of angle CAB equals 18 degrees. If I want to find the measure of DBC now, I'm going to plug 18 back into 4x. I'm going to take 4 times 18 there. So it's going to be 40 and 32. That's going to give me 72 degrees. Okay, so that's how we can use these angle relationships to set that problem up. Let's do one more example, and we're going to have to deal with our verbal descriptions here. If angle R is supplementary to 47-degree angle, and angle S is supplementary to 56-degree angle, could they be vertical angles? All right, so I can't believe I didn't say that earlier. Let me go back real quick. One thing to mention about vertical angles that I did not say earlier is that vertical angles are congruent. Okay, so I labeled from here, I labeled what's what, but I forgot to mention that angle 1 is going to be congruent to angle 2, and angle 3 is congruent to angle 4. Okay, so make sure that you're aware of that. So these are vertical angles here, these are congruent, and here. Okay, but 1 and 3 are not necessarily, so 2 and 4 are not necessarily. They have to be across from each other. So that's non-adjacent is what we're saying. What's a handy little thing here is like this is vertical angles like this. I kind of like this image. You can make an X out of that. It makes a V, it looks like a V and an A. So vertical angles. All right, so back to my example. Angle R is supplementary to 47. So let's find the measure of angle R. The measure of angle R plus 47 equals 180. That's my definition of supplementary. So I do that. I'm going to subtract 47 over. So that I find out that the measure of angle R equals 133 degrees. Okay. Over here, measure of angle S is supplementary to 56. So that means I can take that plus 56, and that adds up to 180. So then we're going to subtract 56 over, so that the measure of angle S is equal to 124. So here's my follow-up question. Could they be vertical angles? No. What I established earlier is that vertical angles are congruent. These are different measures. So since angle S and angle R have different measures, they can't be vertical. Okay, so that's what we're establishing there. All right, so we got a few you try now problems. I'm going to say you could probably try those in class. Again, some of the things to highlight on here. You're looking for some of these angle relationships that we talked about. Okay, so this one's drawing on your own. Kind of go off of some of my images, but try drawing your own. Here we're looking for things like vertical angles. Okay, so it says vertical to EOF, so you should be able to find that. Let's see here, 2 pairs of vertical angles. Yeah, it's a little, yeah. Think of it like this. If I take away OH, you should be able to find 2 pairs of vertical angles. Okay, finding measures of the angles is going to be split up in a variety of ways. All right. Yeah. Given that angle 3 is a supplement of angle 4, and angle 4 is 41, 5 measure of angle 3, very similar to work I already did. This one right here, one thing you can do, if I set up this problem right here with those, what does that form? Forms a linear pair. So my setup would be this: 28x minus 7. When I add 24x plus 18, because they're a linear pair, they're going to add up to 180. okay? Once I find X, I could plug that value back in here and here. And then I'm going to look at a relationship either with these two angles or these two angles, okay? So again, look back at all our angle measures that we looked at. So I'm just going to leave that as a setup so that you can try that on your own. But otherwise, we'll talk about that at another time. All right. So that's it for 4.2. And that's actually it for Unit 4. It's a very quick one. We'll be continuing on with this and getting ready for our assessments then. All right, everybody. Take care.